Hmm. Good morning, dear students. We shall start today's class on time. So, hope I am audible, right? Somebody please respond.
Yes, you are audible.
Thank you. Thank you. We'll start today's class. Yeah.
Sir.
Yeah. So today we will discuss about a switching technique, another switching technique. We call it as virtual circuit, switching. And yesterday we discussed about the switching. What is switching? What is exactly bridging? And we discussed about the static, switching. So we discussed yesterday. So yesterday we discussed about datagram switching networks. So today we discuss about this, internet working. That is, in internet working, switching technique is virtual circuit network. And of course, inside this virtual circuit network, virtual circuit switching, we have one more, very important network type. We call it as ATM networks. ATM networks are nothing but a synchronous transmission mode. So that is one of the network that are used, as virtual circuit networks. So coming on to today, virtual circuit network. So let us take a small example of a virtual network. So look at here, we have an example of few switches. There are switch number 1, switch number 2, switch number 3. There are 3 switches available. And of course, these 3 switches, has a connectivity, different connectivity to various computers. And of course, we have to transmit data from host A to host B. Host A is connected to switch number 1 and host B is connected to switch number 3. How it transmits, that is the concept that we have. So in virtual switching, what happens, it will create a virtual network before it actually transmits the data. It creates a network. It creates a path from starting node to ending node before actually it transmits the data. This is the second technique for switching, that is packet switching, which significantly different from datagram switching network, and uses the concept of virtual circuit. So it establishes a virtual circuit just for transmission sake. Once the transmission is over, this virtual circuit is also removed. So that is one very important thing. So before transmitting any packet, the source node will make a path to its destination so that all the packets will move in the same path. So it is what we call it as virtual path or virtual circuit. So in some books, it is also called as virtual path. So it's a virtual circuit. And of course, to understand how this work, please look at this diagram. I've already, explained, the overall connectivity of, multiple switches. Now, what happens in virtual circuit switching technique? We have two stages. One is connections, setup stage, where it will create a connection, and second one is data transfer, phase. So in first stage, what happens? Connection will be established between the source host and the destination host, and once the connection is established, so what happens? The data will transfer. You can ask me a very good question, sir. Who will uh, creates the connection? Who will set up the connection? There are two people. uh, in olden days, network admins used to set up the virtual circuit. So I think you might have understood a long back up a couple of decades back. So whenever you want to make a trunk call, so you used to call to the telephone exchange and ask for the telephone exchange operator to talk to Delhi, to talk to Chennai, to talk to Mumbai, or to talk to some other city. So you used to call from your landline and you used to request. So only local network, local calls you can make it using landline phones. And the telephone operator is working like a administrator. He used to set the virtual circuit, and later he used to give a connection or a call back, so that you can have talking. So that was the situation. So same similar lines, the computer also, before you transmit, the network administrator used to set up the connection. Once the connection is set up, so later the application can transfer the data. That was in olden style. And today everything is automated. And everything is automated in the sense, what happens directly? So the system itself will create a virtual circuit. The system, that means the computer system itself, it is automated. The programs are written. So those programs automatically, it will, based on the various algorithms, it will create a connection, a virtual circuit connection. And once the virtual circuit connection is set up, so it will transmit the data. So that is there are two types. So one is administrator, network admin used to set up the connection and later transfer. Second one is transferring the computer automatically by itself. That is what you call it as automated systems. So automated systems are right now the latest trend. It is working available, whereas the manual system was old system. It was being followed in the earliest days. Now further, virtual circuit, once it is created, so yesterday we have seen in datagram also we have seen. So forwarding table used to maintain in all the switches. The similar way, the virtual table is maintained. Virtual connection table, VCT, virtual connection table is maintained across all the what do you call switches. So there is a virtual table. There is a virtual table created in switch 1. Same way in virtual 2, virtual table is created. Virtual circuit table is created in switch 2. Same way virtual connection table is created in switch 3. So based on this virtual connection table, so the further transmission used to happen. So during the connection setup phase, what happens? The virtual tables are created, virtual circuit tables are created, and all the entries are made in that. So that is the job. That is the job of the virtual connection stage. Once a virtual connection is done, data transmission used to happen. So that is the thing. So now let us see how exactly virtual connection table, what are the various fields that are available in virtual connection table. Let us discuss. Okay. In the connection setup phase, it is necessary to establish a connection state in each of the switches between the source to the destination. I think from source to destination, I have taken the previous, in the previous slide, I have taken very simple example, but in the real world, you will have a lot of switches participating between the source and the destination. And what happens at every switcher, what happens, virtual connection table is created. Virtual connection table is created across all the switches that are participating in between source and destination. And that is the first thing. The first thing. Second thing, in the connection state of a single connection consisting of an entry in the virtual circuit or virtual connection table. So virtual connection table, each in each switch through which the connection passes. Yes, exactly. And one entry in the virtual table on a single switch contains. So here I have given a small example. See, look at here. I have given a small example. So this example, this virtual circuit has an example. Look at here. These are all the virtual circuit table entries. So what it will have an incoming interface. It will have the VCI, incoming virtual circuit identifier. So each and every link is identified by a number. We call it as VCI, virtual connection identification. So it is a number. And outgoing interface is nothing but outgoing port, and outgoing VCI. VCI is nothing but virtual circuit interface. So identity. So interface identity. So that is what I think you might have observed in the previous slide. You have observed in the previous slide. I think if I take you to the previous slide, you can see here. So there is an identification 11. So this link between switch 1 to switch 2, it is called as 11. So, and switch 2 to switch 0, it is called as 7. And it is just like that. Each link is identified by a number, link number. We call it as virtual circuit identifier, along with the port numbers. Of course, anyhow, ports are there, 0, 1, 2, 3 ports. These ports are, with respect to switch. 1, 2, 3, 0, 1, 2, 3 is with respect to switch. 0, 1, 2, 3 is with respect to switch. But the connection between the connection between switch 1 to switch 2 is named as virtual circuit 7. And from 1 to 2 is virtual circuit identification number 11. So it is just like that. So each link, so maybe this link between switch 2 and switch 4. So there is a link. That link is given by number, and computer host A to host switch. There is a link that is also a virtual connection identification number. Virtual connection identification number is a number that generally it is given. Okay, that's what you can see. It's a unique identification. Virtual circuit identifier, that is a unique identification number that uniquely identifies the connection at this switch, and which will be carried inside the header of the packet that belongs to the connection. Yes. So this virtual circuit identifier is the number that will be placed inside the header. So if you take any packet will have two parts. One is a header part, another one is body part. So in the header, it will be holding. And this identifier, based on this identifier, what happens? There is an entry that will be made in virtual connection table. So that is, it will look like this. So interface from this is a example. This is an example of one of the switch. In the one of the switch, the incoming interface is 2. So from port number 2 it will come, and port number 2 is connected to incoming link number 5, and outgoing port is interface is 1, and outgoing interface link number is 11. So it is just like that. So it is the kind of thing. And of course, an incoming interface on which packet arrives at the switch, the incoming interface. So incoming, what is the interface? Interface is nothing but the port number through which the incoming packet will come from some switch or from some host computer. So it is coming. So that is the thing. And an outgoing interface. Outgoing interface is the port number where the packet leaves from the switch. And of course, this virtual connection table is maintained in every switch, and whatever the interface, incoming interface and outgoing interface we are talking about, it is related to that particular switch. And the potential different VCIs, virtual circuit identifiers, will be used for outgoing packets as well as incoming packets. So that is the link numbers that certainly we have. So you can see it has been written in the header. In the header of the packet, 11 is written. In the header of the packet, it is written 7. So that means there is a link. There's a link. So the link number is mentioned here, so that it becomes very easy for the switch to transfer the packets from one switch to another switch, one link to another link. That's very easily can be done. And of course, let us assume a network administrator wants to manually create a new virtual connection from host A to host B. So I told very clearly, virtual circuit is created two ways. One is with the help of a network administrator. Another one with the help of automated computer system. Automatically it will host. Automatically it will work. Automatically it will work. And the first administrator needs to identify the path through the network from A to B. So what are the different paths available from A to B? What are the different switches? He will find out. Okay, in the example figure, there are only one path, but in general there may be many different number of switches. May not be the case. And of course, the administrator picks the VCI values, virtual circuit identification values, that is currently unused for each link for the connection. So he will assign which are not being used. He will assign manually. He will make a connection. He will certainly considers the connection. And once he sets up the connection, of course you can see the same circuit he has written, he has used, and of course, for the purpose of our example, uh, let us suppose that VCI value 5 is chosen. 5 is chosen for the link from link to host A to switch 1. So the link between this host A to switch 1 is we call it as a virtual circuit identifier, the link number 5. Okay, we have considered it as 5. And similarly, from uh, 11 is chosen for switch 1 to switch 2. So it is, so this 11, this 5, it is it has been allocated, it has been chosen, it has been allocated by the administrator. And of course, which are all the link available, numbers available, VCIs available, he will choose and he will allocate. He'll allocate that so that the same entry is maintained in the virtual circuit table. So here you can look at the example. Here you can see the example here. So in this example, so we have chosen this as 5. So virtual circuit is between A and this one is 5. I'm sorry, A and this one is 5, and this is 5, and virtual circuit number 5. A and switch 1 is 5. Switch 1 to switch 2 is 11. Switch 2 to switch 3 is 7. Okay. So what happens? You certainly write. So this is a virtual circuit table entry in the case of switch 1. Okay. So the packet is coming from A to switch 1, and the interface is nothing but port number. Port number is 2, the same port number we have written here. And incoming VCI is virtual connection identification, it's 5. Yes, we have done. And outgoing interface means port number is 1, the same one port number we have written here. And same way, the outgoing VCI identification is 11. So same 11 is written here. So this is how it is maintained in the switch 1. This is how it is maintained in switch 1. Similarly, so we can have in switch 2 also. In switch 2 also we can have. Look at here, the incoming interface is 3, and incoming VCI is 11. Of course, 11. This link is called 11, so 11 is written. Outgoing interface is 2. Yes, port number 2. And outgoing line is 7. Yes, 7. VCI is 7. We have written. This is the entry in virtual circuit entry maintained, virtual circuit table entry maintained at switch 2. Same way, virtual circuit table entry maintained at switch 3. The incoming line is 0. So incoming port number or interface is 0, and 0 is written. So the identification VCI is 7. So same 7 is written here. And the outgoing interface where host B is connected is 1. So port number 1 is written here. And similarly, we will identify this outgoing line as 4. So this line is identified as 4, whereas this line is identified as 5. So between A and switch 1 is 5. Between switch 3 and B is 4. So same 4 is written here. You can see same 4 is written here. Outgoing identification, a link. So interface link is identified as 4. So this is how the table entries are made. Once the table entries are completed across all the switching stations, so your virtual circuit is established. So that is connection establishment happens. So during connection establishment, administrator will identify, first point, he will identify all the participating switches. and in each participating switches, he will find what is the incoming interface, what is the incoming VCI, what is the outgoing interface, what is the outgoing VCI. That entry he will manually make across all the switches. He names all the links. He maintains all the switches, virtual circuit table, virtual connection table. So once that is done, connection setup is done. Once connection setup is done, based on this virtual circuit table, what happens? Whenever you transmit a packet, automatically the switch looks into the virtual circuit table, and just whatever it is mentioned in the virtual circuit table to that particular thing, it will just forward the packet. It will just forward the packet. So that is what we see. That is what we see here in virtual circuit. Uh, technique in virtual circuit technique. That is in connection setup phase. Once the connection is set up, then the packets will be transmitted. Switch will just refer to the virtual circuit table and just transmits. That's the only procedure that we have. So, and there are types of circuits. I have already said the virtual circuit is generally created by administrators. So when admins creates a virtual circuit, so that if the network admins creates a virtual circuit, configures the virtual circuits, they are called PVC, permanent virtual circuits. Of course, once the virtual circuit, the transmission is over, what happens? That administrator will delete it. Administrator will delete it. So, and releases all the circuit, numbers to the pool, and another virtual circuit administrator, he will take the same, VCIs, and he will use it in his virtual circuit, connection. So if network administrators establishes a virtual circuit, that virtual circuit we call it as permanent virtual circuit. And sometimes what happens, alternatively, the computers itself, they are automated systems. Artificial intelligence is imbibed, and automatically it will set up the connection. That is, entire virtual circuit can be established automatically by the computer itself, the host itself. This is referred as signaling virtual circuit. So why it is called signaling virtual circuit? Because these virtual circuits are automatically created based on sending signals to the all networks, switching stations, and once the virtual circuit is created, then it will transmit the data. This is what every day we are seeing in our mobile phones. Whenever you want to make a phone call, so what happens? It will take, after you type the phone number and click on the dial button, so automatically it will take 2 or 3 seconds, maximum 10 seconds, just to find out where is the destination host. And once the destination is located, it will create a virtual circuit by making all these entries automatically. See, within 10 seconds, every switching stations are identified, and virtual circuit tables are updated, and connection is established. And once connection is established, the phone start ringing in the receiver's mobile. And once he accepts the phone call, so automatically the data transmission happens. Here data transmission is voice call. Same voice call will be happening. So this is one example that is what we call it as example for virtual signaling, virtual circuits. So this is automated systems, so that we are experiencing every day. The salient characteristics of signaling virtual circuit, that is SVC, is that host may set up, delete such VCs dynamically without the involvement of network administrator. Here, network administrator will not come into the picture at all. Automatically, your system, your mobile, your phone, or your system will automatically take care. It takes care of the entire operation. So that is one very good thing, and that's why even today we are using all these things. Today we are using all these things, and of course, yeah. So one example for this virtual circuit is uh, X.25, or we call it as ATM networks, asynchronous transmission mode, ATM, are well-known virtual circuit based on networking technology. In the examination, a lot of questions will be asked. A lot of questions will be asked on this ATM, networks. Okay, so probably if you study ATM network is also called as X.25. So asynchronous transmission mode, ATM networks are nothing but asynchronous transmission mode, which is probably the most well-known virtual circuit networking technology, through which somewhat in the past it is peak in terms of deployment. ATM become very important technologies in 1980s, early 1990s, for variety of reasons. Not the least of which is it was embraced by telephonic industry. So mainly it is being used by telephone industry. So during that time, landline connections were there to handle that landline connections as a network. So they use this ATMs, and of course, it was very much popular during 90s and 80s, which had historical been less than active data communication. So this is so the picture of ATM cell frame format is given here. You can see ATM cell. So you have GFC, you have VPI, we have VCI. What is a type? What is CLP? What is HEC? And what is payload? We'll discuss. This is the you know the frame format. So let us see what is GFC. Okay. So same I have just taken here. VPI, VCI, type, CLP, HEC, all those things. The first one, GFC, is nothing but generic flow control. So why this is being used? Generic flow control. If two systems are transmitting data, one may be faster, another may be slower. Just to hold this uh, difference, so this GFC is being used, is a field that provides local function, such as identification of multiple stations that share a single ATM interface. It is typically not used. So, and of course, in India, all telephones are of same speed. So now it is set to 0. Whereas now, in case of mobile phones, this GFC will come into picture, because some mobiles are fast, some mobiles are slower. It will have different configurations, different memory, different memory and other details. So that is the reason. So GFC is being used. Second one, VPI, virtual path identifier. Virtual path identifier is nothing but is together with virtual circuit identifier. Of course, it is to identify the virtual circuit along with the cell that is directed as it passes through an ATM network. It is the name of the path. Okay, VPI is the path, virtual path identifier. It is the identification path, the number that is being used along with the VCI, virtual channel identifier or circuit identifier. So through ATM networks on the way to its destination. And of course, along with the VPI, we also have VCI. VCI is virtual channel identifier or circuit identifier is used with along with VPI to identify the virtual circuit along with the cell that will be directed to its pass through an ATM network on the way to its destination. So normally there are 31 different VPIs are available, 0 to 31. So 31 different parts. And remember, sir, you can ask me a question. Sir, why both VPI and VCIs are used? Both VPI and VCIs are why it is used. Of course, both are used for identification number. Yes. So this is a common question. Most of the students, they ask. Remember one thing, ATM network when you are using, you are not the alone person using. You're not the only person using. So what happens? Multiple people are using. Many people are simultaneously using. Many people. So when many people are using, maybe there may be a common path, but many people are using. So in order to distinguish one virtual circuit path with another virtual circuit path, so this VPI is used. So maybe the channel identifier is same, but path is different. Some part of the path is common. So in order to differentiate the two different paths of virtual path identifier, VPI is used, and virtual channel identifier will certainly use for each link. Okay, that is the reason. So ATM networks are better than what VCIs that we are having, because in virtual circuits, there is only one connection we can set up. Only one person can transmit the data between the source node to destination. All the switches are blocked to only one host and one destination. So that was the case. But in ATM cell, it is not like that. Only, you can establish the path, but path is not reserved for you. So same path can be used by other applications, other communicators, other source, other destinations also, so that multiple transmission happens. When multiple transmissions are happening in different virtual paths, so each path is identified as a number, so that is being used here. VPI 1 and VPI 2, virtual path 1 and virtual path 2. It is being used. Further, we have a type. So type is actually a 3-bit data that is there in the format. So what happens, each bit, very important. The first bit contain what type of data that you are carrying. Whether you are carrying the user data or you are carrying control data. Control data is to control, is to generate control signals, control information, like circuit establishment control information, or the acknowledgement information. We call it as control information. And uh, uh, this user data is having the packets that are having user data type of packets will certainly have the data exactly from the user, and it will transmit. So control frames, control frames or control packets will just be used for inter switch communication or inter host communication. So whereas the data frames or data packets will carry the data among networks, among interconnection of switches. Second bit is identifies whether there is a congestion or not. So congestion notification is also being sent. What is congestion? Congestion is nothing but jam, traffic jam. So if there is a traffic jam, what happens? The switch